You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is Cursor's real-time RL transforms AI code composer performance. Here's a quick overview. Cursor introduces real-time reinforcement learning for Composer, enabling dynamic code generation optimization that adapts to developer patterns and improves accuracy on the fly. Now, let's ask our analyst about these developments. What's new? Cursor's real-time reinforcement learning for Composer?
Cursor has launched real-time reinforcement learning capabilities for its Composer feature, marking a significant advancement in AI-powered code generation technology. This update introduces dynamic learning mechanisms that continuously optimize code suggestions based on developer interactions, acceptance rates, and coding patterns. Unlike traditional static AI models, Cursor's real-time RL system adapts its behavior during active coding sessions, learning from immediate feedback to improve subsequent suggestions. The implementation leverages a hybrid approach combining online learning algorithms with contextual bandits to balance exploration of new coding patterns with exploitation of proven successful suggestions. The technical architecture employs a multi-armed bandit framework with Thompson sampling for suggestion ranking, while incorporating developer-specific preference modeling through implicit feedback signals. When developers accept, reject, or modify suggestions, the system immediately updates its policy weights, adjusting future recommendations within milliseconds. The RL agent maintains separate policy networks for different programming languages and coding contexts, allowing for specialized optimization across diverse development scenarios. This approach enables the system to recognize patterns such as preferred coding styles, library usage preferences, and architectural decisions unique to each developer or project. Previous versions of Cursor Composer relied on pre-trained models with periodic batch updates, resulting in suggestions that remain static throughout coding sessions. The new real-time RL implementation represents a fundamental shift from this approach, enabling continuous adaptation that can identify and respond to emerging patterns within individual coding sessions. Early testing indicates a 23% improvement in suggestion acceptance rates and a 31% reduction in the time required for developers to achieve desired code outcomes. The system also demonstrates improved handling of edge cases and novel coding scenarios that weren't well represented in initial training data. Multi-armed bandit framework with Thompson sampling for dynamic suggestion ranking separate policy networks optimized for different programming languages and contexts, millisecond level policy updates based on developer acceptance and modification patterns, 23% improvement in suggestion acceptance rates compared to previous static model approach, 31% reduction in time to completion for coding tasks across beta testing cohorts.
Thank you for that analysis. Let's move on. Who benefits from Cursor's real-time RL Composer update?
Professional software developers working on complex, long-duration projects will experience the most immediate benefits from Cursor's real-time RL implementation. Teams building enterprise applications, microservices architectures, or domain-specific solutions particularly benefit from the system's ability to learn project-specific patterns and coding conventions. Developers working with newer frameworks or emerging technologies see significant value as the RL system adapts to unfamiliar patterns faster than traditional static models. Senior engineers leading code reviews report improved consistency in generated code as the system learns team preferences and architectural decisions throughout development cycles. Freelance developers and consultants working across multiple client projects gain substantial efficiency improvements as the system quickly adapts to different code bases, style guides, and technical requirements. The real-time learning capability proves especially valuable for developers switching between projects with distinct architectural patterns or coding standards. Development teams using agile methodologies benefit from the system's ability to evolve suggestions based on sprint-specific requirements and emerging patterns within iteration cycles. Educational institutions and coding bootcamps report enhanced learning outcomes as the system adapts to individual student progress and common misconception patterns. Developers working primarily with well-established, stable code bases may find limited immediate value from the real-time RL features, as these environments offer fewer opportunities for adaptive learning. Teams with strict coding standards that rarely deviate from established patterns might not fully utilize the system's adaptive capabilities. Organizations with limited development activity or infrequent coding sessions may not generate sufficient interaction data for the RL system to demonstrate meaningful improvements over static model approaches. Enterprise development teams building complex, multi-component applications, freelance developers managing multiple client projects with varying requirements, educational institutions seeking personalized coding assistance for students, agile development teams with evolving requirements, and iterative development cycles.
Great insight. Really helpful context. How to get started. Step-by-step real-time RL setup.
Before enabling real-time RL for Composer, Ensure you're running Cursor version 0.42 or later with an active Pro subscription. The feature requires stable internet connectivity for continuous model updates and sufficient local processing power to handle real-time inference adjustments. Verify your system meets the minimum requirements: 8 GB RAM, modern multi-core processor, and at least 2 GB available disk space for local model caching. Back up your current Cursor settings and workspace configurations before proceeding with the RL activation process. Navigate to Cursor settings and locate the Composer section that enable real-time reinforcement learning from the Advanced Options panel. Configure your learning preferences by selecting aggressive, balanced, or conservative adaptation rates based on your development style and risk tolerance. Set up feedback sensitivity levels to determine how quickly the system responds to your coding patterns. Higher sensitivity provides faster adaptation but may be more volatile with inconsistent feedback. Initialize the RL system by completing a brief calibration session where you code for 15 to 20 minutes in your primary programming language, allowing the system to establish baseline preferences. Monitor RL performance through the integrated dashboard accessible via the status bar indicator showing real-time adaptation metrics. The dashboard displays suggestion acceptance rates, learning velocity, and confidence scores for different coding contexts. Adjust adaptation parameters if you notice suggestion quality degradation or overly aggressive learning behavior. Enable detailed logging to track how the system evolves its suggestions over time, particularly useful for understanding adaptation patterns across different projects or coding sessions. Ensure Cursor version 0.42 plus with Pro subscription and stable internet connectivity. Enable real-time RL from Composer settings and select appropriate adaptation rate. Complete 15 to 20-minute calibration session in primary programming language. Monitor performance through integrated dashboard and adjust parameters as needed. Enable detailed logging for tracking suggestion evolution and adaptation patterns.
That's a very interesting point. Tell us about competitive context. How real-time RL changes the AI coding landscape.
Cursor's real-time RL implementation establishes a significant competitive advantage over GitHub Copilot and other AI coding assistants that rely on static model inference. While Copilot provides consistent suggestions based on pre-trained patterns, it cannot adapt to developer-specific preferences or project context during active coding sessions. JetBrains AI Assistant and Amazon Code Whisperer similarly operate with fixed model parameters, limiting their ability to optimize suggestions based on real-time feedback. Cursor's approach enables dynamic optimization that competitors cannot match without fundamental architectural changes to their inference systems. The real-time learning capability positions Cursor uniquely in scenarios requiring rapid adaptation to new code bases, emerging frameworks, or evolving project requirements. Traditional AI coding tools struggle with domain-specific patterns or unconventional coding approaches that weren't well represented in training data. Cursor's RL system addresses these limitations by learning from developer interactions, creating personalized suggestion models that improve over time. This approach proves particularly valuable for enterprises with unique architectural patterns or proprietary frameworks that generic AI models handle poorly. However, Cursor's real-time RL approach introduces complexity and potential inconsistency that some developers may find challenging. The adaptive nature means suggestions can vary significantly between sessions as the system learns, potentially creating confusion for developers expecting consistent behavior. Static model approaches offer predictable, reproducible suggestions that some teams prefer for collaborative development environments. Additionally, the real-time learning requires continuous data collection and processing, raising privacy considerations that may concern security-conscious organizations. Unique adaptive capability versus static inference models used by GitHub Copilot superior performance with domain-specific patterns and emerging frameworks potential inconsistency challenges compared to predictable static model behavior privacy considerations due to continuous data collection for learning optimization.
Good analysis. Let's continue. What's next? Future implications of real-time RL in code generation?
Cursor's roadmap indicates expansion of real-time RL capabilities to include multi-developer team learning, where the system aggregates patterns across team members while maintaining individual preferences. Upcoming features include cross-project pattern recognition that enables the RL system to apply lessons learned from one codebase to similar contexts in different projects. The development team is exploring federated learning approaches that could enable knowledge sharing across the broader Cursor user base while preserving privacy through differential privacy techniques. Integration with version control systems will allow the RL system to learn from code review feedback and merge request patterns. The broader ecosystem implications suggest a shift toward personalized AI development tools that adapt to individual and team preferences rather than providing generic suggestions. This trend may pressure competitors to develop similar adaptive capabilities or risk losing market share to tools offering personalized experiences. Integration partnerships with major IDEs and development platforms could extend Cursor's real-time RL capabilities across diverse development environments, creating a more comprehensive adaptive coding ecosystem. Long-term prospects include the development of specialized RL models for different software engineering disciplines, such as DevOps automation, testing strategies, and architectural design patterns. The success of Cursor's real-time RL implementation could accelerate adoption of adaptive AI systems across other development tools, from debugging assistance to code review automation. However, the approach to success will ultimately depend on demonstrating consistent value improvements that justify the additional complexity and resource requirements compared to traditional static AI coding assistance. Multi-developer team learning with aggregated pattern recognition capabilities, cross-project knowledge transfer, and federated learning implementation integration with version control systems for code review, pattern learning, specialized RL models for different software engineering disciplines and workflows.
Great analysis. So, what are the key takeaways from all of this?
Enable real-time RL in Cursor Composer settings to achieve 23% higher suggestion acceptance rates through adaptive learning. Complete the initial calibration session with 15 to 20 minutes of coding to establish baseline preferences for optimal adaptation. Monitor the RL dashboard regularly to track adaptation metrics and adjust sensitivity settings based on coding patterns. Consider the trade-off between adaptive suggestions and consistent behavior when implementing in team environments.
And what market signals should our listeners watch for?
Adaptive AI development tools emergence. Cursor's real-time RL implementation signals a market shift toward personalized AI coding assistants that learn from individual developer patterns. This trend challenges the dominance of static model approaches used by established players like GitHub Copilot, potentially forcing industry-wide adoption of adaptive learning mechanisms. The success of this approach could accelerate investment in reinforcement learning applications for developer tools, creating opportunities for specialized AI companies focusing on adaptive software development solutions. Enterprise demand for customizable AI tools. The real-time learning capability addresses enterprise requirements for AI tools that adapt to proprietary code bases and unique architectural patterns. This development indicates growing market demand for AI solutions that can handle domain-specific requirements without extensive retraining or customization efforts. Organizations with complex, specialized development environments may increasingly prioritize adaptive AI tools over generic solutions, creating competitive pressure for vendors to develop similar personalization capabilities. Privacy-preserving AI learning methods. Cursor's approach to real-time learning raises important questions about data privacy and model personalization that will likely drive innovation in federated learning and differential privacy techniques. The market is moving toward AI tools that can provide personalized experiences while maintaining data security and privacy compliance. This trend suggests increased investment in privacy-preserving machine learning methods and may influence regulatory approaches to AI tool data collection and processing practices.
What should developers and operators do with this information?
Enable real-time RL immediately if you're working on projects with unique architectural patterns or frequently switching between different code bases. Wait 2 to 3 weeks if you're in the middle of critical project deadlines, as the initial adaptation period may introduce suggestion variability. Implement team-wide adoption only after individual developers complete successful calibration sessions and demonstrate positive adaptation metrics. Consider disabling for pair programming sessions until you've established stable personal adaptation patterns to avoid suggestion conflicts.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.